This is not a permissible installation because the generator voltage must match the service voltage. Attempting to connect a 480-volt generator directly to a 240-volt service is unsafe and violates electrical codes. Doing so can result in equipment damage, fire hazards, and potential injury. If the generator were installed with the service rated at 240 volts, the KVA rating would be calculated as follows. The original KVA is 104. The voltage ratio is 240 divided by 480, which equals 0.5. Therefore, the adjusted KVA is 104 multiplied by 0.5, resulting in 52 KVA. Similarly, the adjusted KW rating would be calculated using the same voltage ratio. The original KW is 83. Multiplying 83 by the voltage ratio of 0.5 yields 41.5 kW. These calculations demonstrate the significant reduction in generator capacity when operating at a lower voltage. While the generator switch and the service switch are rated at 300 amps and 400 amps respectively, and the transfer switch is service rated at 400 amps. This is acceptable, as the transfer switch is only used to connect the generator to the service. The amperage ratings of the switches themselves are less critical than ensuring the voltage compatibility between the generator and the service. The primary concern is always the voltage mismatch, which, in this case, renders the installation impermissible. When selecting a generator for a residential application, it is crucial to verify that its voltage rating matches the service voltage of the building. This ensures safe and efficient operation and prevents potential hazards. Furthermore, all electrical installations must comply with applicable codes and regulations. Consulting with a qualified electrician is highly recommended to ensure that the generator installation meets all safety requirements. The following points summarize key considerations for generator installations. Firstly, voltage compatibility is paramount. Secondly, proper wiring and grounding are essential. Thirdly, overload protection should be implemented. Fourthly, compliance with electrical codes is mandatory. Fifthly, regular maintenance is necessary. Ensuring voltage compatibility involves selecting a generator with a voltage rating that matches the service voltage of the building. For example, if the service voltage is 240 volts, the generator must also be rated at 240 volts. This prevents voltage imbalances that can damage equipment and create safety hazards. Proper wiring and grounding are critical for preventing electrical shocks and ensuring the safe flow of electricity. All wiring connections must be secure and properly insulated. The generator must be grounded according to electrical code requirements to provide a path for fault current. Overload protection is necessary to prevent the generator from being overloaded, which can damage the generator and create a fire hazard. Circuit breakers or fuses should be installed to protect the generator from overcurrents. Compliance with electrical codes is mandatory for all generator installations. These codes are designed to ensure the safety of electrical installations and protect people and property from electrical hazards. Regular maintenance is necessary to keep the generator in good working condition. This includes checking the oil level, cleaning the air filter, and inspecting the spark plugs. Neglecting maintenance can lead to generator failure and potential safety hazards. In addition to these key considerations, it is important to understand the different types of generators available. There are portable generators, standby generators, and inverter generators. Portable generators are small, lightweight generators that can be easily moved from one location to another. They are typically used for temporary power outages or for powering tools and equipment at construction sites. Standby generators are permanently installed generators that automatically start when the power goes out. They are typically used to power essential appliances and equipment in homes and businesses. Inverter generators produce clean, stable power that is suitable for sensitive electronic devices. They are typically used for camping, RVing, and other recreational activities. When selecting a generator, it is important to consider the power requirements of the appliances and equipment that will be powered. The generator should be sized to handle the maximum load that will be placed on it. It is also important to consider the fuel type that the generator uses. Generators can be powered by gasoline, diesel, propane, or natural gas. Gasoline generators are the most common type of generator, but they are also the most expensive to operate. Diesel generators are more fuel efficient than gasoline generators, but they are also more expensive to purchase. Propane generators are a good option for people who have access to propane tanks. Natural gas generators are the most fuel efficient type of generator, but they require a natural gas line to be installed. Once the generator is selected, it is important to install it properly. The generator should be installed in a well-ventilated area to prevent carbon monoxide poisoning. It should also be installed away from flammable materials to prevent fire hazards. The generator should be connected to the electrical system by a qualified electrician. After the generator is installed, it is important to test it regularly to ensure that it is working properly. The generator should be tested under a load to ensure that it can handle the maximum power requirements. It is also important to check the oil level and the air filter regularly. By following these guidelines, you can ensure that your generator is installed and operated safely and efficiently. Remember that the generator's KVA and KW ratings are significantly reduced when operating at a low voltage. So voltage compatibility is the biggest concern.